Hey y'all, happy Sunday and welcome to this week's live Q&A session. This is the portion of the show where we allow YouTube to send out notifications that we're going live. If you're watching this live Q&A on replay, please scrub ahead until this graphic disappears and the actual show begins. If you're watching live and you have any comments or questions, please go ahead and put them in the live chat. But for now, grab a beverage, sit back, and relax while the countdown timer does its thing. Then we'll get started. Aloha, happy Sunday. Oh, man. It's all just another day that ends with what? Happy day, y'all. Hope everybody's doing well. Hope the world's treating you better than you deserve. I mean, count my blessings every day, and folks ask me how I'm doing. Better than I deserve. So, today, I kind of wanted to start this with a topic, but I didn't have an idea for a topic until I had a discussion with a couple of my members, channel members, a couple of days ago for information on how to become a channel member. Check below this video panel. You'll see a join button. More on that later. We have a great group of people. Love to have you join. We're going to get to that topic pretty quick. But first, a couple of things. If this is your first time here, please note that I have subscribers only mode turned on. And that is to root out all the bots and trolls who like to pop in and try to take over a chat for live streams. I don't know. Some folks just need a hobby, I guess. And some folks, that is their hobby. Sucks to be them. What can you say? So I have that set up to where you have to be a subscriber to my channel for at least one day before you can participate in the chat. So subscribe now, then you can join us in the chat next week. Sorry it has to be that way, but that's the world we live in, you know. The other thing I want to do is I want to give a shout out and wave with both hands in an excited way to my friend Steve over at Harneal Media. I've been singing Steve's praises for years now, and I know I sound like a broken record, but that's okay. I'm willing. I believe in Steve, and I believe in Harneal Media that much. If you are even toying with the idea of maybe you want to progress to a website, and you don't know where to turn to, the only person I'm ever going to recommend is Steve over at Harneal Media. Why? Well, it's simple. It just works. Everything just works. If there's an issue, he's on top of it. If there's a problem or a request, if you want a web store, he's got you covered. That way you can offer your products and services to the public at large without dealing with commissions, without dealing with listing fees, and without having that listing service advertise your competition on your page, as happens with too many of them. If you're thinking that it's time to take control of your business, be it large or small, you owe it to yourself to get over to Harneal Media and hit that contact us link, shoot Steve a message, and just have a chat with him. You know, even if it's just to find out some more information and see what all's involved, he'll talk to you. And that's one of the beautiful things about Harneal Media is the fact that it's all 100% personalized service. When you are dealing with Harneal Media, you're talking to Steve, not some nameless, faceless person in a call center somewhere that you're never going to have any contact with again. So enough about that for right this moment, but do yourself a favor. Head over to harnealmedia.com and hit that contact us link. You're going to find a link to Harneal Media in every website. Well, yeah, in every website I have control over. You're going to find a link to Harneal Media in every video and every live stream on this channel, and it's that way for a reason. Do yourself a favor. Get over there and do it. You'll be glad you did. Thank you, Steve, for everything, and I truly appreciate everything you do for me, and I mean that. Okay, as I said earlier, I was having a chat with a couple of my channel members, and they kind of helped me figure out what topic I was going to discuss today. And that is 3D model placement. And what I mean by that is not so much in X and Y, but where in the material vertically that model is to be placed. There was some discussion about wanting a model recessed with a rim left around it, and how would I go about doing that? So what I'll do is I'll go ahead and bring up the screen share here, and we're going to do this in VCarve Pro, just basically to show that this works in VCarve Pro and Aspire. So you VCarve folks, you get to play too. What I have here is I have just a toucan that's out of the VCarve Pro clip art. Jump over to the 3D view and you can see how he looks. I mean, pretty okay. Something I forgot to do when I was setting this up was I forgot to check the component height. So I'm going to go into my components tree, right click, go into properties, and he's 0.5447. Let's just make him an even 1/2 inch tall. And let the program catch up, and then I'm going to close that. Go back into my design tab. Now here's what I mean when I start talking about model placement. Going back into the 2D view, we can see that I've got the model placed in the center of my material, and I've got these two vectors here. This vector is going to be the outline of the project. This is my my cutout vector. So when I go to cut this out with a 1/4 inch end mill, that's the vector it's going to follow. This inside vector here is a space I want to carve this down and leave the model standing proud down in the bottom of this pocket. So the top of the model is going to be recessed, and then I'll have this pocket all the way around it. So how do I go about that? Well, let's go over here to the Toolpath tab, and what should pop up automatically if I go to do a roughing toolpath or a finishing toolpath is the material setup. That should pop up automatically, but it doesn't always. Now, this is one of those cases where going into material setup is important, and in fact it's crucial with all 3D models, because the software doesn't know where within the thickness of the material this model is going to be. So we'll go into material setup, and we get a little bit of information up here at the top. The active sheet is sheet 1. Yes, we're only using one sheet for this. My material thickness is 3/4 of an inch. My XY datum is in the center, and we're showing a detailed summary on the Toolpath tab. Okay, and that's up in here when we close this. My Z0 is to the material surface, and here is the pertinent thing, the model position in the material. Now we're talking about within the thickness of the material. Right now what it's showing me is my model thickness is a 1/2 inch. My modeling plane is negative 1/2 inch. Now what that means, let me jump into the 3D view here. If I rotate this, we can see this kind of tan-ish gray plane here. And if we look at this representation of the thickness of my material, we can see that that plane is down here, a 1/2 inch into the thickness of the material. So that means the very top of this model is going to be the surface of the material. This is what's meant by placement. Now, I have a slider over here, and I have this drawing this representation of the thickness of my material, I can drag that down and you'll notice the colors change. I've dragged that down to the bottom, so now that modeling plane is at the bottom of the thickness of my material. Now, if I'm just going to be cutting this out, that may be what I want, but that's not what I want for this particular model. Now, what I have going on here is I have a model thickness of 1/2 inch. As it's set right now, I have a gap above the model, meaning the gap between the top of the model and the top surface of the material. Right now, that gap is 1/4 inch. That's too much because it's going to cut all the way through the material. So if I drag this up a little bit, let's say I want to go 1/8 inch. Now my model is in the center of my material. But what this means is when I go to cut this out, when I go to carve this, the model doesn't start for 1/4 inch. So it's going to have to carve through the material 1/4 inch before it gets down to the top surface of the model. Now, what that's going to do is when it carves this model, it's going to also carve away this pocket because I'm going to use this as my machining boundary. And we'll get into that in just a second. What I want is I want this to be a rim left at the material thickness. Then this over here, again, is my cutout. So I'm happy with that. I'm going to try that. Let's see what 1/8 inch looks like. Then I'm going to come down here. All of these, my rapid gaps, my home start position looks okay. I'm going to click OK. And then I'm going to go into, I'm just going to do a finishing toolpath. I'm not going to bother with a roughing toolpath for this demonstration. If I were actually going to go carve this, I would use a roughing toolpath. So I'm going to go over here to the 3D finishing toolpath, and I already have a couple of bits loaded in here. It remembered the bits I used for the last finishing toolpath I saved. There's an 1/8 inch ball nose, which I think is fine, and a 1/16 inch tapered ball nose, which I think is fine. It's going to just fill in the little details that are too small for that 1/8 inch ball nose to get into. Here's one of the important parts. The machining limit boundary. I have several selections. I can go with the model boundary, which basically is just going to carve the model itself and leave all this the same thickness as the material. Then I have the material boundary, meaning it's going to carve everything around the material boundary. Don't want that either. Then I have selected vector, in which case I'll select this vector. That's the vector it's going to carve this to. So it's going to carve the model and then carve this area flat all the way to this circle. I am not going to use a boundary offset. This is one of the few times I will go without a boundary offset. And that's because I want the bit to stop at this circle. I don't want it to go beyond. And that's what a boundary offset would do. Now, how am I going to carve this? Because it's a circle, I could go with a offset strategy, but I tend to get a better surface finish if I use a raster strategy. And the raster angle of 45 degrees. Now what that means is the bit's going to go side to side but at a 45-degree angle, and carve all of this. Now, something to be aware of. When 3D carving, the 3D finishing toolpath does not respect the pass depth that you have set for the tool. So make sure your carve is going to be safe for the bit you're going to use. This 1/8 inch ball nose, I think it can handle it. I might go, if it was any deeper than this, I would go with a 1/4 inch ball nose. But that goes back to doing a roughing tool path first. Do a roughing tool path so it clears away the material. Then you don't have that concern, because most of the material will be carved away. I'm not going to concern myself with this right at the moment. No boundary offset. I'm going to leave everything else as it is. Raster, 45-degree angle. And I'm going to call this 3D Finish 1 because we're going to do a couple of different 3D finishing toolpaths to see what it looks like. And let's go for the gusto here. And it's going to create 2 toolpaths. The first toolpath being the clearance pass. And that's going to be using that 1/8 inch ball nose. The second toolpath is the finishing pass, and that uses that 1/16 inch tapered ball nose. And we can see them illustrated out here. They're drawn. If I turn off this one, we can see that's what the 1/8 inch ball nose is going to carve away. Let me turn that off, turn this one on, and that's what that 1/16 of an inch ball nose is going to carve. It's going to come in and fill in these details, and that's it. So I'm going to click on the clearance pass first, and I'm going to preview it. Now, this may take a while. We'll see. I don't know. The processing with the way I have everything set up could take a while, and I've got a lot of things going on this computer, but actually it's going faster than I had imagined. So, but we can see what it's doing. We're actually getting the carve placed down inside a flat bottom dish, which is exactly what we were after. Go back to the top view. Let's see what's going on here. All right, and there we are. Now it's left that toucan carved down in the bottom of this dish. And that's left me roughly 1/8 of an inch thick bottom here, which is fine. That works out perfectly for what I want to do with this. Now we'll come back up here to the top, go to the finish toolpath, and preview that. And again, it's just getting those little fine details that 1/8 inch bit could not reach. And that actually looks pretty good. Let me come out of the preview. We've got one more toolpath to calculate, and that is our cutout. So I'll select this vector. And for my cut depth, I want it to go all the way. So Z equals. And I want to select my end mill. For this, I'm going to use a 1/4 inch 2-flute downcut end mill. Select that. It's going to do it in 3 passes. I want to carve to the machine to the outside of that vector. If I were going to actually carve this, I would do a separate last pass. I might add tabs depending on how I mount the material. But as it sits right now, I'm not going to worry about it for this demonstration. I would add ramps. There are no corners to worry about. So I'll just call this cutout. and we'll calculate it. And we will preview it. And get rid of the waste by double clicking. And there's the finished project using these thicknesses and this depth. Now 8 Center has a very valid point here. Wouldn't 1/8 of an inch base be at risk of warping? It certainly would. It certainly would. But it depends on what you're going to do with this project here. If you were going to fill this with epoxy, say you wanted to embed certain things over here that remind you of a trip where a toucan would be a good tropical memento, and you had other mementos of a weekend you spent or what have you, then it would be okay. But if this was just going to be carved on its own, this might be a little bit deep. You would either want to go with a thicker material. If you needed this depth of a 1/2 inch, you might go with a thicker material that would help. 8 Center says, I was asking about tray bases a few days back, and they say don't go thinner than 5-6 millimeters or 1/4 of an inch. Yeah, that's pretty good. I tend to err on the side of caution, and I tend to go with 3/8 of an inch base, which gives me that basically splits the material in half. I've got a 3/8 inch base and 3/8 inch to play with for model thickness and model depth. Mike Bernasconi says the outside rim will warp. That's very, very likely. It's also going to depend on grain orientation, meaning are you carving this, is your material flat sawn? Is it quarter sawn? Are you carving this into end grain? All of these things are variables and factors that need to be taken into consideration, because no two materials are going to warp, expand, or contract in the same way. By the same token, if you do this in MDF and you're going to paint this toucan and maybe give it a different color base, then all bets are off. You can do what you'd like because the MDF isn't going to warp as long as you seal it, meaning either with a paint or a clear coat, or both, a clear coat after you've painted it. So there are a lot of variables to consider when you're doing something like this, especially something this deep. I find that if I'm working with flat sawn material, as long as I keep those angular rings looking like an upside down U, then I'm fine. If they look like a right side up U, you're going to get more cupping than you would if they're facing the other direction. It's not going to eliminate warpage. It's just going to reduce the amount. You're still going to get a little bit of warpage if you're carving this deep into solid stock. This is exactly why people tend to do things like this on a panel that's glued up. Because laminate panels, you have smaller surface area that can warp or cup. It's not to say that laminated panels won't. It's just they're less likely to, and it's going to be less drastic. Laminated panels warp all the time, but they're easier to deal with than one 12-inch wide piece. So every piece of material has internal stresses that we can't see, and you don't know how it's going to react until you cut into it. And that's the same with if you're seeing, or if you're just cutting it on a table saw. The minute let's say you slice a 12-inch piece into 2-inch wide strips, each one of those strips is going to have its own individual stresses. And that, I mean, all you have to do is cut a couple of wide pieces. And when you see, let me come back, let me come back in here. Let's cancel the spotlight. When you are ripping a wider piece and you see the piece that you're ripping start to bend in, start to curve in, and start trying to pinch your blade, that's because you are releasing the stresses in that material, and that's the way it wants to warp. Sometimes it'll warp away. It'll bend away from the blade. And it's kind of a 30-30-30 shot as to whether it's not going to do anything. Is it going to warp inwards? Is it going to warp outwards? You just don't know what's going to happen. It could also just kind of banana up. So it's just kind of, you're guessing. However, once those stresses have been released and we joint, plane, machine, however, the material flat again, they tend to be more stable. And then gluing them up to other panels, gluing them up to other pieces, actually help counteract some of that warping and twisting and bending. So all that to say that yes, you are going to get a little bit of warpage when you remove this much material. Which direction it goes is up to nature, and nature always wins. And that's the thing that we deal with all the time working with wood, is it continues to move long after the tree has been milled, long after the project has been finished, long after we've moved on to other things. So wood always moves, and there's nothing you or I can do to prevent it. So let's see here. We're going to go, no, I don't need to go back. What I want to do is I want to go back into here. And I want to look at this a little bit closer. I want to look at not only my model placement, my model position, I want to also look at the model thickness, because that's a contributor. Right now, this model thickness is a 1/2 inch, but does it need to be? The conventional wisdom is accurate, but the conventional wisdom is the thicker the model, the better the relief, and the more detail you're going to get from that relief. However, it's not always appropriate, and it's not only something we can control. So what I'm going to do here is I'm going to change the overall model thickness. And I'm going to do that right here. I don't need to go back into properties. So what I can do is I can just click on this set button right here, and I can enter a new model height. So I'm going to change that to 0.25. We're going to do pretty extreme here, just to kind of demonstrate. I'm going to click apply, and you'll notice that changed out here. That model is now 1/4 inch thick. I'll close this window, and it's reflected here. Well, now I don't need that huge gap above the model of 3/8 of an inch. I can click in here and I can take that back to 0.125, and that gives me a 3/8 inch thick base down here to help prevent some of that warping. Now, it's true, I don't have as much relief in this model, but this is where we got to look at, is that much relief really necessary? So it's going to be your priority, what you think it needs. And here we also have a little bit of cushion. We can we could actually go up to 1/4 inch here of a gap if we wanted to, if we wanted this really deep. But I'm going to go ahead and try this with the 3/8 inch base. I'm going to click OK. Now it's going to ask me here, the material setup values have changed. Changing of any of these settings means all toolpaths must be recalculated to ensure correct results. Would you like to recalculate now? If these were the only toolpaths I was going to calculate, I would click yes. But because I'm changing this so I get a different result, I'm going to calculate new toolpaths. I'll click no. Now, go back into the 2D view. I'm going to select my inner vector again. I'm going to do another separate 3D finishing toolpath. Let's see here. And you're only using a 16th bit too, so you wouldn't get super high detail anyway. True. And again, the use of the 16th inch bit is just to get into the places that 1/8 inch bit is a little bit too big to get into. But because I have reduced the thickness of the model, I've also reduced the amount of relief in the model, so that has flattened out a lot of that detail. So going with a smaller bit, a bit smaller than this, may not benefit me much anyway. So again, it's a game of give and take. So all of this has been remembered from the last toolpath I calculated. I've got the ball nose 1/8 inch and the 16th inch tapered ball nose. I'm machining to the selected vector. No boundary offset. Raster, 45-degree raster angle. And this is going to be 3D finish number 2. I'll calculate. Now, what this is doing is, again, it's calculating separate toolpaths, separate from these. Now I'm going to reset the preview, and we're going to see what these two look like. So I'm going to go ahead with the clearance pass first. I'm going to preview that. We're cutting much shallower. My Z position right now, if you look at my readouts that show up down here, my Z position is negative 0.375, which means I'm 3/8 of an inch down inside the material, and that's the bottom of this dish. I've still got another 3/8 of an inch of base height here. And actually, even though the relief is much less on this model, it still looks pretty good down here. I'm not losing as much detail as I thought I would. Of course, we're also only looking at the 1/8 inch bit. And that actually looks better than I thought it would, being only 1/4 of an inch thick. Again, the conventional wisdom is the thicker you can make the model, the taller you can make the shape height, the more relief you'll have and the more detail you'll get. But it's not always feasible. It's not always possible. Again, it's a game of give and take. Now let's look at what that 16th inch bit does. The biggest difference is going to be up here along the face of the toucan. The eye gets a little more detail. That groove gets a little more detail. But the feathers also get a little bit more detail. That's actually pretty good. That's actually acceptable to me. Okay, now we'll do the cutout, and we'll preview that. Double click to get rid of the scrap. And that looks pretty good. Again, it depends on what you're making with this type of carve. The top of the model is still 1/8 of an inch below the top surface, this rim here, but we've not carved as deep into the material in order to achieve that. So this is where I would come over here, save a preview image of this, and then run these toolpaths, save a preview image of that result, and then compare the two photographs and see which one I prefer. Did I preview the 16th inch toolpath? Yes, sir, I did. And that is Let me draw that. That's what it carved. It just did a little bit of detail here, a little detail down here, all the way around, and then up in here along the eyes, the top of the head, and a few things here at the mouth, and a few things down here where the claws are grasping this vine. Now, the question that everybody wants to see is, what about machine times? Well, let's go into the toolpath summary, and I'm going to deselect this. I'm going to select these three here, and going with that 1/2 inch deep cut, we're looking at 7 hours, 46 minutes using my settings. Okay. If I deselect these two and go for the shallower carve, we're still 7 hours. So the only difference in machine time was this is 7:07 and this is 7:46. So the difference being 39 minutes. So roughly a 1/2 hour of machine time is what you save by not cutting as deeper. Now, that's only one thing to consider, though. If you're cutting this, let's say, if you're cutting this out of a single piece of material, now you have to deal with that potential warpage. So how many hours are you going to spend with that? We tend to think of projects in terms of machine time, but it's not done when it comes off the machine. I get teased a lot because I use such fine stepovers. And it's like, you're going to put 7 hours and 46 minutes into this? Yes. I could increase my stepover and it'll take less machine time, but now I got to sand all those cusps out, all those tool marks out of the bottom, and that's going to take time. And I don't know about you, but I don't really enjoy sanding all that much. So I'm going to let the machine do it. I'll let the machine do it. That way I don't have to worry about it. So, I'd rather deal with a 7-hour machine time and not have to sand it for 2, 3, 4 hours. All right, we had a question here from 8th Center. Could you go through the process of rounding over the rim inside and out? Why, certainly, sir. And this is I'm going to show you the easiest way to do it. The easiest way to do it is to figure out what kind of radius that you need. What radius do you want? Do you want a 1/4 inch radius here and a 1/4 inch radius here? Do you want a 1/4 inch radius on the outside and an 1/8 inch radius on the outside, inside? Do you want an 1/8 inch on both sides? Before I get into that, 8th Center says, time only really matters if you're selling, but if you can do the same job quicker at the same level, you take the option you like. Absolutely. If you enjoy spending 2 hours sanding, then great. More power to you. I'm a weekend warrior. I don't sell my stuff. I try to go with the path of least resistance. I'm just going to let the machine do it rather than spend my time in here with the sander. Or worse, hand sanding. Okay, so you want a 1/4 inch radius for both. Easiest way to do that is to go out and get yourself a 1/4 inch point cutting roundover bit. I happen to have those. So what we'll do is we're going to do a profile toolpath. And I want my cut depth to be slightly less than the radius of the bit. So with a 1/4 inch roundover bit, I'm going to use a cut depth of 0.23. I'm going to change my bit to quarter-inch radius point cutting round over bit. Select it. It says it's going to take it in 4 passes. I can live with that. Here's the important part. We're going to machine on the vector. We're going to machine on the vector. Actually, what I can do, hold down Shift, and I can select both of these so I only have one toolpath. All right. And we're going to call this round over. And we're going to calculate. All right. So we're machining on the vector with that round over bit. We got one tool path. We're going to preview it. Zip and zip. And there you have a round over that doesn't quite go to the top. But I'm here to tell you, you will have some hand sanding to do on this. You will have some hand sanding. And that's going to remove this ridge, but you're going to want to sand this area anyway. Now, just to demonstrate what that actually looks like, let me go back into here and I'll change this to 0.25 just to show you what it will look like once it's sanded nice and pretty. And we're going to undo last, which is that round over. Now we'll run them again. Zip and zip. Now we have a point right here in the center that I don't really fancy. So again, that's why I tend to do that. Now maybe 0.23, undo last. Maybe 0.23 was a little too drastic, so let's go with 0.24 and see how that works. 10th thou does make a difference. And we'll calculate that. And we'll preview that tool path and zip and zip. Okay, we got a little bit of a flat spot here, but that can be sanded nice and smooth. That's the easiest way. No 3D carving involved. No 3D modeling involved. Get a bit with the radius that you want. Make sure it's a point cutting round over bit. And I've got a bunch of them. I've got several here. Let's go tool paths. Whoops. Tool paths, tool database. I've got several. I've got 1/8 inch radius, 3/16 radius, quarter radius, and 3/8 radius. And all of them point cutting. And, you know, they do work very well. So just plan to sand then. For the most part, yeah. Now, having said that, that little peak that ran when I did the when I created the toolpath to cut to 0.25, that little peak, you'd have to sand that down anyway. Now, if that doesn't bother you, then you do you, go for it. And this is what I mean, experiment. My experience has been that no matter how flat your material is, there's always going to be some variation in the top surface. And what you don't want is you don't want that. Let me go back in here to the tool database. And let's go down to that round over bit. Yada, yada, yada. Nope, that's metric. Where are the other round over bits? Where did I go? Round over, there we are. 1/4 inch radius. You don't want this top edge here, this corner, to get down into the surface. You don't want it to get down into that surface, and because then you start cutting a recessed round over, and you don't want that. Because this is a cutting edge here. And how tall that cutting edge is depends on the bit. Also notice that for this particular bit, it doesn't come to a complete point at the tip. Okay? It doesn't come to a complete point. Most round over bits don't come to a infinite point down here. So that brings about something else. If we look really closely at this preview, we see a mark right here. That is a very tiny step. It's a little flat spot right there where that tip cut into the side. If we look over here, we don't have that. It's because it used the other edge, basically. So for this out here, I would use a boundary offset. Go back in here. And or allowance offset, excuse me. And then, you'd have to dial it in and see if you're dealing with a negative or a positive allowance offset. And just try in the preview until you come up with a number. And then I generally make that note in the tool. Now, 8 center has a point to make here. I suppose if you round over first, then profile, you remove that outer lip. I always round over first. Always. Let me just go ahead and close this. And top. Let me go ahead and go back into the preview. We'll reset the entire preview. I'm not going to do the 3D model. I'll just do this tool path. We'll preview them. Then I will do the cutout, and we'll preview that. And we'll click, get rid of the waste, and it's still there. The reason it's still there is because of that flat spot. Now, what I can do is I can also go into my cutout toolpath and set an allowance offset there. I want it to move in. That's a positive move. So let's try 0.01. Let's just see. Yes, because I want it to move inward. Calculate, and we'll reset the preview. I'll run the round over first. Run the cutout second. And I still have that line. Let's take a look. It's bigger. It should have been negative. All right. Reset preview. Let's make that a negative. All right. And calculate. Now we'll preview the round over. Then we'll preview the cutout. Boom, it's almost gone. Almost gone. Let's reset the preview and try 12th thou. 2. And calculate. Now I'm just doing this for me. And we'll go with round over first. And then we'll do cutout. We'll see how this works. 12th thou. That was the magic number. So by doing an allowance off, no, I still got a little bit there. Let's go with 13th thou. And let's try this. Calculate. Round over. Cut out. Now we're good. Now we're good. That edge is gone. Okay, so to be true to myself, what I just said, I'm going to go up here, tool database. I'm going to go to that 1/4 inch roundover. Where you at, Mark? There you are. And in the notes, I'm going to put -0.013 allowance offset. Now, I put negative in there. It doesn't have to be negative. In fact, you know what I'm going to do? I'm going to go back to the beginning. No, go back over here. There we are. And I'm going to delete that negative. I know now that I need to use a 13 thousandths allowance offset to make up for the tip of that bit. So click Apply to save that note, and then click OK. Little side note here. I'm going to go back to that. Tool Paths, Tool Database. The notes that you can put on a bit can include links. And so let me click on that link. Oh, I got a control click, excuse me. Control click, and of course it opened in this other window, and it opened a link to that bit. Now, I'm the one that supplied that link. I created that link. So, there it is. Now I can go order another one when this one gets too dull to use. So, you can put links to bits or whatever in the notes here. Okay, click Apply to make sure they're saved. Click OK. That's just another one of those little tips. Okay, I see some things here. Wipe it with a piece of 220 and you're done. Not necessarily the case. This isn't my first rodeo. I played this game before. Quick run with a spindle sander works also. Yes, unless it's on the inside of the rim, like we have here with this toucan. Rich Bratcher wondering, doesn't it depend on inside or outside? It does, and that's why I took out that negative, because I didn't want to marry it to that number. It's going to depend on whether I want it to go to the inside or the outside. But now I know what that offset is. So, also, I just made a change to my tool database. So I got to go back into the tool database, and I'm going to upload it to the cloud. So I'm going to upload it. This will overwrite the last database on the server that was updated on the 2nd of November. Yes, I wish to continue. Tool database has been uploaded to the server. Now when I go into the house and get on that computer and open up vCarve, get into the tool database, it's going to tell me, as you've seen here a few times, it's going to tell me that the tool database is out of date. There's a new database on the cloud. Do I want to download it? Yes. So this database and the one in my design computer in the house will be the same database. So click OK, and I'm done with that. So that's basically it as far as model placement is concerned. The software doesn't know what you're going to be doing with this model. It doesn't know where you want it within the material. And this is what's going to decide where it's placed, right here. So Let's see here. And by the indicated direction of the cut on the little side window with the vector on, inside or outside. Yes. And let's throw that out there again also. That's a good point. In the 2D view, you have a few things here. If I'm going on the cutout, okay? I draw the cutout. This is selected. This is make visible. So I've got the toolpath selected. The check mark makes it visible out here. I can turn that off, and it's not visible. This is a visible toolpath. This is a selected toolpath. And they don't have to be the same. That's a selected toolpath. That's a visible toolpath. Enough semantics. I have two different ways that I can view this. Right now I've got this brown line with these arrows. That is the wireframe view. But there's another way of looking. And that is right here. Toggle toolpath 2D drawing style. Wireframe or solid. I can click on that and it's going to show me a solid view of where that bit is going to cut. So we can see I went with a positive offset allowance on my cutout, and it moved it 13th thou inside that vector. If I remove this allowance offset and recalculate it, it'll put this solid blue right on that vector. So you have a couple of ways of seeing how it's going to cut. You can look at it wireframe, or you can look at it solid. This comes in real handy when you need to zoom in and see exactly where that bit's going to cut. It'll also help you to see whether this should be negative or positive. Because if you, well, let's just do positive. Get rid of that negative symbol. Calculate the toolpath. Now I come into the 2D view. I don't even have to run it to see where that positive offset took me to. I don't even have to run the preview. I can just look. So now if I come back in here, put that negative right there, and calculate, go back into the 2D view, and I can see I'm back in there and I've got that negative 13 thousandths allowance offset. So let me go ahead and turn that back over to wireframe. And wireframe is the default, by the way. It's going to draw it in the wireframe. And you have to come into the 2D view and click on that icon. And it'll toggle it over to solid. Okay. Close here. Let me go ahead and come back in. And we'll take that down. Let's see. 1122 Waldo. Sounds like an address. Sorry. Is one brand of sandpaper better than the other brand? That's like asking, is chocolate better than vanilla? It's like asking if strawberry is better than both. My opinion may not match with anybody else's, and everybody else's opinion may not match with mine. It's kind of what you find works best for you. And also what you're working with. If I'm using a sanding block, or I'm doing a 3-fold paper to use by hand, I like Norton brand. Always have. If I'm running it on my random orbit sander, I'm using the 3M Cubitron, 3M Extract Cubitron paper, because dust collection is important. If I'm hand sanding, Again, I like Norton, but it doesn't necessarily have to be Norton. And it depends on what I'm doing. If I'm doing something by hand, I'm starting with 220 and going up to 320, I'll use Norton. If I'm doing a fretboard and I need to go up to 4,000, I'll use, let's see, the company, I get it at automotive stores. I want to say it's Bondo brand, but I could be wrong. But that's generally speaking, like I said, for you're into polishing then. But the guitar fretboards have to be nice and smooth and absolutely 100% splinter free. Otherwise, you're going to have one cheesed off guitarist knocking on your door, wanting to use that guitar as a club. For power sanding, it depends. I mean, a lot of people like Klingspor for drum sanders. I don't have a drum sander. So I can't comment on that, but it depends on what you're doing with it. So I prefer fabric backed sandpaper rather than paper backed, says Robert. You know, I think they both have their place, but I tend to agree with you. I like a fiber back, like an emery cloth or something similar, as opposed to the paper backed. But unless I'm wet sanding. If I'm wet sanding, I don't care because I'm going to throw it away anyway. So sandpaper is one of those consumables. It's just going to get tossed. But then again, you know, your results may vary. Some people get a real good finish using the El Cheapo Harbor Freight sandpaper. It just depends on what you're doing, what you like. If you're getting, here's what I say to everybody about anything. If you are getting a good result, you're doing it right. If you're getting a predictable result that you like consistently and safely, no matter what it is, you're doing it right. You're doing it right. So, your knowledge is better than mine. Well, thank you for that, but I don't know that that's one of those things that basically you get through experience, because what works for me may not work for you. I will give you one tip though. If you're hand sanding and you're having to put a little bit of effort into it, get you some of that first aid tape. Just standard old first aid tape, and wrap it around the tips of your fingers. And then when you get in there and sand, it's a cushion between you and that sandpaper. And it's one more layer to help. Well, number one, it'll remove you a little bit from the friction of the sandpaper rubbing against whatever it is you're sanding. Give you a little bit more control and give you a little bit more padding so you can push a little bit harder should you need to. Believe me, if you've ever had to sand anything for 8 hours a day, you take every trick you can get. And I was shown that by a woman who was in her 60s at the time. And she was a Russian immigrant. And she did that every time she had to touch sandpaper. She'd take a minute and wrap a little bit of first aid tape. The first aid tape you get at Wally World or the grocery store or whatever for holding on gauze bandages. And just wrap a layer around to protect your fingers. And I tried it because I thought, yeah, no big deal. I tried it, and oh boy, it makes a difference. Let's see, excuse me. Man, beverage break. Okay, we had a question earlier. Let me get to it. I am not ignoring folks. T. Patterson wants to know, hey Mark, is there a setting somewhere to raise the bit up when it's going to make the next cut? The bit would not raise out of the workpiece and cut it in half. For situations like this, my mantra is, and I'm going to have to make a sign and put it up behind me, always check the mechanical first. Always. The reason I say that is because settings don't change themselves. If you've been using your machine and it's working fine, and then suddenly it doesn't work fine, always check the mechanical first. Unless you went and changed a setting, all your settings are the same. This is a mechanical failure. I can almost guarantee it. I don't know your machine. I don't know how it's put together. I don't know anything about it. If you have a coupler between the motor and lead screw or ball screw, check that coupler. And don't just look at it, because you can't tell if it's loose or tight. Take whatever Allen wrench or whatever you need and tighten it. Just assume that it's loose and tighten it. In fact, you know what I'm going to do? I have a video on, basically it's an aid to troubleshooting. I'm writing myself a note here. And I'm going to put a link to that video down in a pinned comment when we're finished with this live stream. So it'll be the first comment there. I made a video, oh my goodness, a long time ago. It was one of my first videos, I think, on the subject of CNC. And it had to do with just putting slippage marks on your couplers. And that gives you a way to look and see at a glance as to whether or not that coupler slipped on either the motor shaft or the shaft of the lead screw or ball screw for your Z-axis. Okay? If either one of those is loose, you can't tell by looking at it. You can only tell if you have a mark there that should be lined up, and all of a sudden it's not lined up. They should be lined up, not like this. That indicates a slip. Steve is on it. The man is on it. See what I mean? I mean, come on. I'm going to put a link to that video in a pinned comment as soon as we're finished here live. Now, it may not be that coupler, but that gives you a way to eliminate that right from the get-go, because you can look at that slippage mark on the ball screw or lead screw side and then look at it again from the motor side. That may not be it. Let's see here. I think it was Sam Spade who said, yeah, had a project ruined by bit slippage. That's another factor. You may not be tightening your collet tight enough. Or your collet may be defective. Let me go grab a collet here. I'll go with the 1/2-inch collet because it's easier to see for y'all. Take it out of the collet nut. Ooh, this needs to be cleaned. Wow. Okay. Collets are, you see all those slots. Some of those slots go to the top. Some of them go to the bottom. It's a giant spring. And as you tighten it in the taper of the spindle, it collapses. It squeezes the shank of that bit. Collets break. Collets wear out. Collets are consumables. You need to replace them if you look inside and you see a line, a ring, where it looks like something has spun in there. If it looks polished to where it's nice and shiny, that indicates slippage. Um, or if you're looking at some of these areas along the side here and you see a crack, if you see a crack or you see any kind of defects, this is an accident that is found a place to happen. It's just waiting for the appropriate time. These are replaceable. They're not expensive. You can pick them up on Amazon. There are a lot of places online where you can get collets. I'll put a link to my favorite place to get collets if you're using a router like the Makita router or something like that. I just wrote myself a note to post a link to that company in the pinned comment as well. All right, snap that back of the collet nut. That's another thing to look for. Are your collets fastened in the collet nut? That should not shake out. You should be able to hold that upside down and shake it till the cows come home, and that should not come out of there. It's real easy to just drop it in and shove it up in the taper. That ain't how it goes. Not all collets and collet nuts are created equal. If you look at mine, you'll see a little half moon shape at about the 12 o'clock position on my collet nut. That tells me which direction. It tells me where to push to get the collet in and out. It should snap into place so that it didn't snap into place. Now I got to find it. Let me get another collet. That's the kind of thing that can lead to bit slippage. Exactly. Sam Spade says, thanks, the collet was cracked. Yep, okay. Time to order a new one of them. And now that I've dropped that one and got to track it down, I might have to order a new one of them. They're not expensive. Figure on $20, if that. You know, you can get them in sets sometime. Sometimes they come with the nut, sometimes they don't. Do a little bit of due diligence and see what's going on. Now, that's another possibility. But what you had was you had something that made it didn't lift up enough. It didn't lift up enough. It also depends on whether you were using an upcut or a downcut bit. A downcut bit wants to push chips down into the material, or down into the cut. An upcut bit wants to throw chips up and out. If the collet is loose and you didn't snug it up enough, what can happen is, as it's cutting, it's trying to throw chips out, but that's also pulling down on that bit. And if it slips, I've had that happen. Using an upcut bit, clearing out a pocket, and then Z lift up, well, it's pulled that bit out about 1/4 of an inch. And then it dragged over right through the rim of that project because the bit had slipped down out of that collet and it just cut right through it because it didn't lift up enough. So there's multiple things at work here, and there's multiple variables it could be. Generally speaking, if you have used the machine and it worked fine, it's still fine. Settings don't change themselves, with one glaring exception. I'm talking to you, Microsoft. Windows updates will change Microsoft settings, but it should not change settings in GSender, Mach 3, Mach 4, Centroid Acorn, Universal G-Code Sender. It should not change any of those settings. It will change a ton of settings in Windows, but it shouldn't change any settings in your apps or programs. So I keep coming back to it. If you made no changes in any of your settings before that happened, it's a mechanical issue. Always check the mechanical first. So be it your machine, your bits, your spindle, your router, your collets. It's another thing to look at. Is your router mount or spindle mount, is it tight? Did that spindle drop a little bit? Things happen. There are a lot of moving parts when it comes to a CNC router. If you've been running it for more than 6 months, do the Brits call it a spanner check. Go around with a wrench, the appropriate size wrench, and just tighten nuts and bolts. You'll be surprised at the number of them that are just a little bit loose. Check belt tensions if you have belts. The rack and pinion system like mine, it has belts for the rack and pinion system. Like check belt tension. That's the time when you go around, wipe everything down and give it a lube. But take a wrench, the appropriate size wrenches, go around and check nuts and bolts. I try to do that 3 times a year. Maybe more often if I've been running it hard. So, 8 Center says, yeah, there's a lot of up or down force, enough to lift heavy hardwoods. Seen that on a few people's videos. If it's enough force to snap a 1/4 inch diameter carbide bit, it's enough force to throw a piece of material across your shop. And you don't want that at 18,000 RPM. Things get real exciting real fast, and not in a good way. So, okay, we went way off topic here. But then again, I hope that answered your question. The causes of something like that could be it could be multifold. Yeah, Mike brings up metric bits in imperial collets, or the other way around. Yeah, make sure your collet matches the bit. Don't try to use a 6mm bit and a 1/4 inch collet. It might look like it. It might hold it enough to keep it from dropping out. But the minute that touches the material, you're in for a bad time. Be very careful. You don't want a bit coming loose at the speeds some of these things run. Believe me. So, okay, I'm going to go ahead and end this. I've got a collet to track down, and thankfully it's indoors, and I'm not outside in the deep grass or something. Oh well, this too shall pass. Channel members, tomorrow we have one of 2 things going to happen, and I don't know which it's going to be. I got to do some talking in the background. I thought we were going one way. We might end up going another way. Who knows? All I can tell you is it is not going to be Aspire only. The VCAR folks will get their, you'll get to play too. So that's tomorrow. Check the posts/membership tab on my YouTube channel for the link to tomorrow's members only live stream. It will be, we have not changed the time this week because I forgot to announce it last week. It will be at 5:30 Pacific, 8:30 Eastern this week, and we'll change times next week. More on that later. See what else. Okay, that's it on that topic. If you don't know what the heck I'm talking about, or if you'd like some information on how to become a channel member, you can join the super secret Facebook group. You can join the super secret Facebook chat, Facebook Messenger chat, or I've created a WhatsApp group for Mark Lindsay CNC channel members. If you want to get involved in that super secret WhatsApp group, we'll teach you the secret handshake, the whole thing. Just look down below. There's you'll see the word join. Click that join button. And you're not joining anything. You're just looking for information. another video is going to pop up and play. That's going to tell you all about channel membership. We have a great group of people. We'd love to have you join us. I'm blessed to know these folks. This is the finest group of people I've ever seen assembled in one place. We really have a good time. And, some of these people I'm now considering parts of my family. It's that good. We'd love to have you join. Next week, I'm not sure what we're going to talk about. Again, there will not be a edited, pre-recorded video until after the new year. Let me take a look here at the calendar. Yes, this coming Thursday in the U.S. is Thanksgiving. I hope you and yours get together with family and do things that we all should be doing more of throughout the year. We wish you a safe, pleasant, friendly, and blessed Thanksgiving. For those of you who are not in the U.S., this isn't Thanksgiving for you. Call your mom. Just call your mom. She wants to talk to you. If you're like me and your mom has passed, call your kids. Just hug a relative. Reach out to somebody. Somebody out there hasn't heard from you in a while and would truly love to hear from you. It's the time of year, man. I know I get a little bit sentimental, but that's just me. Have a happy Thanksgiving, y'all. And we'll see you members tomorrow. Everybody else, we'll see you next weekend. Have a great week. Thank you for joining me, spending part of your Sunday. Bye-bye.